guys, Mr. Rosario here, and today we're going to be taking a look at exponential functions and doing the review so that you can do your very best on this Module 7 exam, and you can also do really well on your segment exam. So vocabulary for this lesson, we are going to be doing vocabulary and some word problems, but this is all we would need right here. We need to understand what the exponential function is. And it is a function because we start with an a value, we multiply by a b value x number of times in order to get a y value. And each one of those y values have they only come from one x. So because we have a 1-to-1 ratio between the x's and the y's, or correspondence, I should say, it is a function. Okay. So let's explore this a little deeper. The x value, which is our input. Some questions will ask you about the domain value or the input values. They are the same thing. That is the values you can put in for x. In this equation, we have all real numbers work. You can put whatever x value you want. And if you do, that will determine how many times you multiply your a value by this b. The b is known as the base or the multiplier. We're also going to call it the multiplier since we are multiplying by b. Notice that b can be expressed as a number greater than 1 when we are dealing with growth, or a number between 0 and 1 when we're dealing with decay. Because of that, we can also give you what we call the rate of growth or the rate of decay. So every single time you were given a question that has a percentage or a rate, you can change your b value to 1 plus r when it's growth, and it'll look like this. A times 1 plus my rate to the x power. That would determine your growth because we're adding to 1 and which is the decimal value of 100%. So 100% of your value b plus whatever rate you want to add to that will be an increase. If it's decay, we're going to be the same exact thing, but the exponent, the actual b value will be replaced with a 1 minus r. 1 minus r. And that would be your rate of decay. So again, if you're given a rate, for example, I start with $100 in a bank and they decrease at a rate of 20%. Well, that R is 0.2, which is the decimal value of 20%, and we will be subtracting it from 1. So that our $100 are now going to be multiplied by 80%. Which is 0.8 as the decimal value, and just once or twice or however many times you need to multiply that by. And that'll give me a steady multiplier of 0.8 over and over and over, which would be decreasing. In a graph, we expect those values that are decreasing to be going down. And on a graph on a growth, we expect those to go up. Notice that I started with 0, 1 as my intercept. And we'll talk a little bit more about when we talk about a. And on those functions, that's what we have. Okay. I give you that because sometimes you'll be asked about the rate. Given a problem, they'll say, hey, what's the rate if your b value is 0.5? Well, if you know that, you can let your 1 minus r equal to 0.5 and solve for r. And that'll give you your rate of decay. Our y value when x is 0 is what we let our a value equal. Our a is where our starting point goes. More specifically, especially in word problems, since we can have negative time, our x values can only be positive when we're dealing with time, which means our 0, 1 is our starting value. Of course, unless you start out with, like in this example, $50 for your a value. That is known as the y-intercept on a graph, the place where the graph crosses the y-axis. And on a word problem, it is the initial value or the initial condition. Some money problems, we'll call it the principal. But a note to say on A, notice that again, this A value only applies whenever we have X as our exponent. Some of those will have X minus 1 or X plus 1 or X adding or subtracting any other number. If that's the case, then my X value is going to be a little different when Y equals 0. So we'll have to make sure we correct for that. And we have one of those examples to see today. Output. This is our Y values, our final product after we do A times B to the X. And that's what we are left with. These are known as the range values. The range depends where your intercept is at. Okay, so your intercept, well, not to get too complicated, but they will have shifts. Shifts happen when they do H and K movements. So in actuality, this is called the parent function, but you can actually have A times B to the X minus H plus K as your original function, in which H and K determine the vertex or the intercept. In previous examples, I think when you dealing with quads in module 6, which is the one before this one, you saw that represented the vertex of a parabola. So here we can have the same thing. The H is messing with the X coordinates and the K is messing with the Y coordinates. So that your HK is the point of intersection right here. And wherever the K value is, that's going to be determining our range. Whenever H value is, that's going to be determining our input. More specifically, our Y value when X is 0, which is going to be a little different if we don't have this X by itself out here. Notice also that you can have some problems instead of a Y represented as f of x. So that if you see f of x equals a times b to the x, that is the same thing as y equals. We said this is a function, so function notation is also alive and well for this one. And I gave you an example of what it would mean if they have x of 2. That simply means x is now replaced with 2. So they're looking for the y value when x is 2. Okay, so that's the main vocabulary that you have for this section. Let's see what some of these examples look like. Here's example 1. We have a bacteria and is present in some petri dish, and it triples every minute. The amount of bacteria can be modeled by the function given as f of x equals 2 times 3 to the x. And we also know that f of 4 equals 162. So what did the following represent? First one we come across is x. We just learned that x is the input value or the domain values. So y is changing with respect to x, which in this case is the amount of bacteria, which is our f of x, is changing in respect to every minute that goes by. So our inputs are going to be minutes because the change happens every minute. So x would be time in minutes. If you simply put minutes, that is fine. 3, in this case, the 3 is right here. We said that was the base or the multiplier, sorry. So we started with 2 and we times it by 3 x times. So if x equals, well, let's not get too ahead of ourselves. So 3 represents the tripling, which is my b value. So the 3 is the amount of bacteria tripling every time. You could put the tripling effect of bacteria per minute or the growth per minute, anything along those lines. Okay. Tripling. I hope that's how you spell it. Sorry, math. Should have picked an easy one like every doubling. I know how to spell that. Tripling every minute. Alrighty, so feel free to correct me if you send me an email. I'll change that. All right, so for the two is right here. We said that a initial condition or initial value. We have a word problem, which is the way that I'm going to go for this one. So my two represents my original population of bacteria in the petri dish. So in this case, how many bacteria were present at the very beginning? You could also call it the initial bacteria population or how many bacteria were present at the very beginning, anything along those lines. All right, 162, which is right here. This one is the y value when x is 4. So in this example, because 4 represents minutes, this is the amount of bacteria after 4 minutes go by. And that's how we do that. So amount of bacteria present after how many minutes? 4. Okay. And that's an example of a problem breaking each of the components down and explaining what each of them mean. Okay. Let's take a look at another example. In developing an antibiotic for the bacteria in the previous example, scientists introduced a drug compound into the petri dish and recorded their results below. What is the exponential function that represents the relationship between f of t and t? And then a second part is what is the rate at which this drug eliminates bacteria population per hour? So one of the common mistakes I see here for the initial value, a lot of people like to go with the a value as my original problem right here. Even though that is the first point on our table, that is actually not our original value. Okay? That's because according to our definition that we're going with, we have to find the y value when x is 0. So if that's true, let's look at what the b value is. Remember that the b value is the multiplier. In other words, to go from 1600 to 400, we have to be multiplying by some b value. And then we do the same exact b value to go from 400 to 100. That's because we go from 1 hour to 2 hours and then increase by the same rate on my second point. So because I go from 1 to 2 and 2 to 3, by increasing by 1, I'm using the same exact b value. So that means I'm going to look for 1600 times my b to equal 400. Or you could have done the other way, 400 times b equals 100. You get the same answer. Dividing both of them by 1600. This cancels out, leaving me a b value of 1/4 or 0.25. They weren't specific about having a decimal form or fraction form, so I'm going with 1/4. If that's the case, now we have at least a b value so that when we plug it into our equation, we know a times 1/4 would equal my equation, my function. So now I need to find out, going the same exact rate, look from 1 to 0, if there was a 0 here. Now we're going to do the opposite of going up by 1, so we have to do the opposite of multiplying by b, which is dividing by b. And that'll give me my a value, because a is the y value when x is 0, which is right here. So if that's the case, let's see what happens when we do that. So 1600 divided by 1/4 equals A. And that's what we said here. 1600 divided by B, which is 1/4, equals A. So if that's the case, keep it, change, or flip it means we are going to do 1600 times 4 over 1 in order to divide by a fraction. We keep the first one, change this to multiplication, and flip this 4 over 1 to become 1 over 4 to become 4 over 1. So 1600 times 4 means 6,400. So this drug was developed with 6,400 bacteria in a petri dish. And when the drug was administered, what we found out is they decrease 1/4 in its population every t, which is every hour. So what is the function? Well, f of t equals 6,400 times 1/4 raised to the t. Notice that I'm using t values for my exponent instead of x. I used x to solve it because that was our definition, but in this example, t value is my input, which is hours, and f of t is my output. So I make that correction here on my actual answer. So what is the rate at which this drug eliminates bacterial population per hour? Now you might be tempted to say 1/4 is my rate, but 1/4 is the rate, is not the rate of decay, it's the multiplier. To find the rate of decay, we need to find what the B value is and how is it related to the rate. We know it's a rate of decay because it's going down from 1600 to 400 to 100, and it is a value between 0 and 1/4. So my B equals to 1 minus R. We know the B value is 1/4. So how can I solve for R? We'll subtract 1 from both sides. 1/4 minus 1, you might need to get a common denominator. So 1/4 minus 1 becomes 4 over 4. 1 minus 4 now becomes negative 3/4 equals to negative R. Divide both sides by negative 1, and R becomes positive 3/4. So the rate of decay is 3/4 or 0.75. In other words, 75% of the population of bacteria is wiped out by this drug every hour. So that would be this one. Now notice that you can leave it in decimal. I mean, you can turn it into a decimal or to a percentage here as well. 3 divided by 4 in your calculator would be 0.75. Turned into a percentage is 75%. So those are also acceptable. Just wanted to mention that. All right, the next one says, for accounting purposes, the value of assets, the land, building, and equipment in a business are depreciated at a set rate per year. The value V of T of $192,000 worth of assets after T years that depreciate at 18% per year is given by this formula. That 0 is a subscript, so V sub 0, or also initial condition is another way of saying it. You might have seen that in your physics class if you take it, or will take, you'll see it then. So what are the assets valued at after 6 years? And then round to your nearest cent. Or for this one, we're given the equation V of T. My initial value of the assets is also given as $192,000. So that becomes my V sub 0. my B value, we're told that it depreciates at 18% per year. From the last problem, we saw that the B value is equal to 1 minus R. We're subtracting because we're depreciating. So now that we have a percent, again, every time you see a percent, think 1 plus R, 1 minus R. So my B value, which is what they're asking for next, is going to be 1 minus 18%. Can't subtract decimals from fractions. One of them has to change. So I'm going to change the percent here to a decimal. 18% means 18 divided by 100. And 1 minus 18% turns out to be 0.82. So now we have our B value as 0.82. Now notice that they also want you to figure out the depreciation value or the total when the T value is 6 years. So 6 years after the depreciation began, they want to find out what does it equal, which means for T, they want you to put a 6. So how can we find this? Well, in your calculator, I'm going to actually put this all in. I can do 192. Then let me write the key sequence here. Some calculators are going to be different. This is a multiplication. Then you put your point, which is your decimal, 82. Now here's where most of them differ. You could have an X to the Y button. You can have a Y to the X button. You could have a little, the one if you're using your computer is the shift and then the 6. Looks like a little triangle missing the base. Any one of those, some of them have the exponent button. What you want to do is 0.82 raised to the 6th power, whichever one your calculator has. If you want to make sure you can go old school, then multiply by 0.82 6 times. So you would do times 0.82 times 0.82 times 0.82, and then whatever you get will be your answer in this problem. So I'm going to type that in my calculator. Let's see what I get. All right, and when I typed it, I actually got 58,369, and then a whole bunch of decimals. I'm just gonna cut it off there. Now this one says they want it to the nearest cent. Nearest cent is the second value after the decimal. So I'm going to look at the 0, and I notice that it has no bearing on the 8. So my final answer is going to be 58,369.28 cents. So if 18% decrease happens, I'm going to be multiplying 82% times 192,000 6 times. So in 6 years, which is what the T value is, the exponent, my land is worth, all those assets are worth $58,369.28. Whee! All right, next one. Finding the y-intercept. Now you have 4 different scenarios for which to find the y-intercept. Now the y-intercept simply is the place that it crosses the x-axis. So if I have a graph, in this case I do, my y-intercept is 2. If I have a table, we said that it is the y value when x equals 0, which is also given right here. If x equals 0, my y value is 3. So the y-intercept for this one is 3. If I have an equation, well, the a value is right in front multiplied by the b. A value is the same as the y-intercept. So for this one, my y-intercept is 2.5. And on a word problem, like with the one we just saw, it is the amount of, in this case, money that I start out with, which is $12. So my y-intercept is 12. Now on the exam, you'll actually be given 4 problems just like this one, and you'll be asked probably what is the largest intercept or the smallest y-intercept, and you have to know how to find each and every one of these. And that's it. If you know the definition, like we gave it at the very beginning, that's all you need to do. So we have the smallest one, second smallest, third smallest, fourth smallest, all the smallest ones. Another happy face. Happy face squared. Yes. All right. Average rate of change. For the average rate of change, we're going to see that we just pick 2 points to start out from, and then we look at the y values and see how much it changed. So it's just the slope. Slope formula, if you remember for way back in the younger days, is the second y minus the first y divided by the second x minus the first x. So in this example, if I want to go between the x values 2 and 3, well, for my graph, it's easy. I start here, where x equals 2, and go here, where x equals 3, and find out my y values and how much they changed. Which means from here to here, I go 1, 2, 3, up 3 over 1. So my rate of change is 3 over 1, or 3. If you want to go with the list of coordinates, x2, y2, y1, x1, y1, well, my first x was 2, which means when I do x equals 2, my y value for that was 3. If I do my second point, x2, y2, my second x was 3. So when x is 3, this is the x coordinates. When x is 3, my y value is 6. And notice you will get the same answer. y2 minus y1 divided by x2, which is 3, minus x1, which is 2. 6 minus 3 over 3 minus 1 gives me same answer. Now, it's a little different when you have an actual equation like this one, but it is the same exact thing. The average rate of change is the second y minus the first y over the second x minus the first x. The problem with this one, we're not really told what our y values are. We have to find them because we don't have a table, we don't have a graph, so we have to find them. Well, the x values, we're told the third and the fifth year. So that's fancy language for find out if x is 3 and x is 5, what are those respective y values? Respective y values. There we go. In other words, given my equation, what is f of 3? Which is fancy language from the very first vocabulary slide that says if x is 3, what is my y value? Well, to find that out, I'm going to have to do 1.04 to the third power and multiply that by 500. Let me do that in my calculator. That turns out to be 562.432. You could round out here, but you might get into trouble. So it's only 3 decimal places. I'm going to keep it. What about f of 5? That means my y value when x is 5. Using the same function, they just want that x value to be a 5. So when I do that, my y value turns out to be 608.3264512. So now plugging this is going to be my second y. Oops, I did squared. Which, by the way, I didn't say that on the last slide, but that's the major misconception here. That those 2's and 1's are exponents. They are subscripts. They just placeholders. Because you have 2 y values and 2 x values, they just use these bottom numbers to differentiate between them. So you can have the second x minus the first x, and they just tell you which one switch. So we're going to call this one my x2, y2, and this one my x1, y1, which means if I were to plug these in, I'm going to have 608.3264512 minus 562.432 divided by my second x, which was 5, minus my first x, which was 3. Doing this in my calculator, this might take a while, so let me put some hold music. I'm holding on the phone. All right, welcome back. Thank you for that lovely old music, Mr. Rosario. I went to divided by 2. Alrighty, so now I wish I would have put parentheses so I can do it. It's all right. We can do whole music again. Yay! Alright, I put the Spanish station for you guys. Sorry about that. And that means my final answer when I divide it up, 22.94, and I'm going to round to the nearest. There we go. So that gives it the 3 decimal places and 22.947. Usually you want to round this to whatever the instructions say. You only have a few significant digits, so 3 would have probably stopped here at the 9, but that's how you do it. Thank you guys. You guys have a great day. Bye-bye.